So part of our review of geometry, we're going to look at two special right triangles. And the first special right triangle we're going to look at is an isosceles right triangle. So if we were to have an isosceles right triangle, well, essentially there's only one way that can work, is if this is the right angle and this side is congruent to this side. Right, now, if I were to say that this side is A, the length of that side is A, well then that means the length of this side also has to be A. So let's find the length of the other side. So we'll call that X. So let's find the value of X. So we'll start off with the Pythagorean theorem, a squared plus b squared equals c squared. And now, of course, even though this says a, we have these two sides here, so it's going to be a squared plus a squared equals x squared. So then we have 2a squared equals x squared. And if we were to take the square root of both sides, we would end up with the square root of 2 times a equals x. Or what we usually write as x equals a times the square root of 2. So then this becomes a times the square root of 2. And now we have figured out this first special right triangle, the isosceles right triangle. Right, now before we write the theorem down, we're going to actually label this triangle based on its angles. Okay, so you gotta have to think about this. If this here is 90 degrees, that means these two have a sum of 90 degrees, because remember the sum of the interior of a triangle is 180. So these two add up to 90. And if you also remember, the base angles of an isosceles triangle are congruent. So the only way that can happen is if this is 45 degrees and this is 45 degrees. Okay, so this is actually going to be the 45 degree, 90 degree triangle theorem. So 45 degree, 90 degree triangle theorem. Okay, and this theorem states in a 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. And there you go. Simple enough. Alright, so let's go ahead and look at a couple of examples of using this theorem. Let's say we have this triangle here. And we have a right angle here. That's 45 degrees. This is 12. This is x. And this is y. And we want to find the values of x and y. All right. Now the first thing we need to do is determine if this is a 45, 90 degree triangle. And in this case it is, because we're given a right angle. We're given one angle that's 45, so the only way this can be a triangle is if this is also a 45 degree. So this is a 45, 90 degree triangle. This is a 45, 90 triangle. Put little degree symbols there. Okay, then the next thing we do is let's go back to this here. And we're going to label all of these sides either A or A times the square root of 2. So this side over here is A, this side is A, and this side is A times the square root of 2. And then we want to figure out, well, what is A? Well, this one's easy because A equals 12. Now if a is 12, that means, and if x also equals a, that means x must also be 12, which makes sense when you have an isosceles triangle. Now we need to figure out y. Well, y is associated with a times the square root of 2. Well, if a is 12, that means y is 12 times the square root of 2. And there are the two answers. Good. Let's try another example. Let's say we have this triangle here. Oops. Oh well. And we want to find the value of c. So first off, is this a 45 degree, 90 degree triangle? And in this case it is. And the reason we can tell is, well, we got the 90 degree here, and because both of these sides have a length of 10 square root of 2, it means it's isosceles. So the only way you can have an isosceles right triangle is if both of these are 45 degrees. So the answer is yes. All right. All right, now let's get our sides based on these up here. So normally we associate this with a, and this with a times the square root of 2. So if c equals a times the square root of 2, then that means c must be, well, a is 10 times the square root of 2, and then we have the square root of 2. So this ends up being 10 times the square root of 4, which is 10 times 2, and so c is 20. Easy enough. Let's try one more example. Let's see, we have this situation here. And we want to find the value of x. All right, so first off, we need to identify that it is a 45, 45, 90 degree triangle. And it is, because we have the 90 degree and it's isosceles. So the only way that can happen is if these two angles are 45. All right, now let's figure out what each part is. This x is normally associated with a, this is normally a, and this would be a times the square root of 2. All right, now if x is normally a, then what we need to do is find what is the value of a. So we know a times the square root of 2 equals 18. If we divide each side by the square root of 2, we would get 18 over the square root of 2. Now in this case, we do need to rationalize the denominator. So we multiply by the square root of 2 over the square root of 2, which is 18 times the square root of 2 over the square root of 4, which is 18 times the square root of 2 over 2, which is 9 times the square root of 2. So then that means x is 9 times the square root of 2. And there we go. Okay. So here's the first of our two special right triangles. And this first special right triangle is an isosceles right, or a 45, 45, 90 degree triangle. And essentially, if we know the length of these two here, we can get the length of this by just multiplying it by the square root of 2. And vice versa, if we know the length of the hypotenuse, we can get the length of these two by, we end up dividing by the square root of 2.